Experiment transformer PHY205 Physics Laboratory. Voltage transformation, current transformation, turns ratio 1. Objective, verify transformer action. Study the relationship between primary and secondary voltages. Study the relationship between primary and secondary currents. Namadis Tafn 2 apparatus. AC power supply, transformer with primary and secondary coils, voltmeter, ammeter, load resistor/lamp, connecting wires. Ubaraste 3, why transformers? Transformers are used to step up or step down AC voltage without changing frequency. They are essential in power transmission, distribution systems, and many electrical and electronic devices. 4. Basic theory: Vp over Vs equals Np over Ns. Ip over Is equals Ns over Np. Voltage is proportional to number of turns. Current changes inversely. 5. Transformer diagram/circuit of the experiment. Main parts: a C source, primary circuit, primary coil, iron core, secondary coil, secondary circuit, load, resistor/lamp, voltmeter, ammeter, symbols in the circuit: Np, primary turns, Ns, secondary turns, Vp, primary voltage, Vs, secondary voltage times I sub P, primary current times I sub S, secondary current transformer cases, N sub S greater than N sub P implies step up, V sub S greater than V sub P, N sub S less than N sub P implies step down, V sub S less than V sub P. 6. Voltage transformation. When the secondary coil has more turns than the primary coil, N sub S greater than N sub P, the transformer steps up the voltage, V sub S greater than V sub P. When the secondary coil has fewer turns than the primary coil, N sub S less than N sub P, the transformer steps down the voltage, V sub S less than V sub P. 7. Current transformation. If the voltage increases, the current decreases. If the voltage decreases, the current increases. In an ideal transformer, input power equals output power. VPIP approximately equals VS, IS. 8. Important notes/conditions. Transformers work with AC, not DC. Connections should be checked before switching on. Take readings carefully. Do not exceed the rated voltage. 9. Experimental procedure. 1. Connect the primary coil to the AC source. 2. Connect the secondary coil to the load. 3. Connect voltmeters across primary and secondary. 4. Connect ammeters in series where needed. 5. Switch on the supply. 6. Measure primary and secondary voltages. 7. Measure primary and secondary currents. 8. Change coil turns or use different taps. 9. Compare measured ratios with theoretical ratios. 10. Data tables. Table 1. Voltage. Transformation. Np turns Ns turns Vp volts. Vs volts turns muddy. N sub S turns V sub P volts. V sub S volts. V sub S over V sub P. N sub S over N sub P. Table 2. Current transformation I sub P amperes, I sub S amperes, I sub P over, I sub S N sub S over N sub P. Percentage difference, %. 11. Final verification. Voltage ratio matches turns ratio. Current ratio is inverse of turns ratio. Step up and step down behavior observed. 12. Final conclusion. The transformer changes AC voltage according to the turns ratio. Current changes inversely while power is ideally conserved. This experiment confirms the principles of voltage and current transformation. Final relations. Voltage ratio equals turns ratio. Current ratio equals inverse turns ratio.